But what is it expanding into? That's a complicated question. Here's why. Einstein's equation of general relativity describes space and time as a kind of interconnected fabric for the universe. This means that we know of a space and time exists only as a part of the universe and not behind it. Now, when everyday objects expand, they move out into more space. But if there is no such thing as space to expand into, what does expanding ever mean? In 1929, Edward Hubble's astronomy observations gave us a definite answer. His survey of night sky found all faraway galaxies reside or move away from the Earth. Moreover, the further the galaxy, the faster it resides. How can we interpret this? Consider a loaf of raisin bread rising in the oven. The batter rises by the same amount in between each and every raisin. If we think of raisins as a stand-in for galaxies and batter as space between them, we can imagine the stretching and expansion of intergalactic space will make the galaxies recede from each other. And for any galaxies its far away neighbors will reside a larger distance than the nearby ones in the same amount of time. Sure enough, the equations of general relativity predict a cosmic tug of war between gravity and expansion. It's only in the dark void between galaxies where expansion wins out. So there's our answer. The universe expanding onto itself. That said, cosmologists are pushing the limits of mathematical models to speculate what if anything exists beyond our spacetime. These aren't wild guesses, but hypotheses that tackle Keynes in the scientific theory of the Big Bang. The Big Bang predicts matter to be distributed evenly across the universe as a space of gas. But then how did galaxies and stars came to be? The inflationary model describes a brief era of incredibly rapid expansion that relates quantum fluctuation in the energy of the early universe to the formation of clumps of gas that eventually led to galaxies. If we accept this paradigm, it may also imply our universe represents one region in a greater cosmic reality that undergoes endless eternal inflation. We know nothing of this speculative inflating reality, save for the mathematical prediction that is endless expansion may be driven by an unstable quantum energy state in many local regions. However, the energy may be settled by random chance into a stable state, stopping inflation and forming bubble universes. Each bubble universe, ours being one of them, would be described by its own Big Bang and laws of physics. Our universe would be part of a greater multiverse in which the fantastic state of eternal inflation makes it impossible for us to be encountered a neighbor universe. The Big Bang also predicts that in the early hot universe, our fundamental forces may unify into one superforce. Mathematical string theory suggests description of this unification in addition to the fundamental structure for subatomic quarks and electrons in these proposed models. Vibrating strings are the building block of the universe. Competing models for strings have now been consolidated into a unified description and suggest these structures may interact with massive higher dimensional surfaces called branes. Our universe may be contained within one such brane, floating in an unknown higher dimensional place, playfully named the bulk or hyperspace. Other branes containing the types of universe may coexist in the hyperspace. And neighboring branes may even share certain fundamental forces like gravity. Both internal inflation branes describe a multiverse. But while universes in internal inflation are isolated, brane universes could bump into each other. An echo of such collision may appear in the cosmic microwave background, a soup of radiation throughout our universe that's a relic from an early Big Bang era. So far, we found no such cosmic echo. Some suspect these differing multiverse hypotheses may eventually coalesce into the common discrimination or be replaced by something else. As it stands, the speculative exploration of mathematical models, while these models are inspired and guided by many scientific experience, These are very few object experiments to directly test them yet. Until the next Eden Hubble comes along, scientists will likely to be left to argue about the elegance of their competing models and continue to remember what if there is a lies.